valuable information, so you guys don't want to miss it. Alright, so we're going to start by defining a rectangle. I'm sure you guys can draw one. So everybody take a second in your notes. I want you to really quickly draw a rectangle. How about over here? Draw a rectangle over here.
I draw this.
Over here in the margin right here. Go ahead and draw a rectangle for me. Now, when you drew the rectangle, what are some features that you included when you drew the rectangle?
All rectangles.
Did you actually draw corners that have 90 degrees?
Yeah.
Now you are. Okay. So 90-degree angles, what else is a feature of a rectangle? All opposite sides across from each other? Does that mean that all four of them have to be congruent necessarily? No, just opposite sides. How many sides does it have?
4.
4. That's also an important detail. So we're going to go ahead and define a rectangle. It is a quadrilateral.
Really?
Yeah. With 4 right angles. This is all that needs to be happening in a shape for it to be qualified as a rectangle. All it needs to have is 4 sides where all of the corners, all 4 corners are 90 degrees. The relation between the sides is actually irrelevant to describe it as a rectangle. It just needs to have 4 right angles to be qualified as a rectangle.
A square is a rectangle?
Correct, a square is a rectangle.
Exactly.
Okay? So that whole thing you guys were telling me about the opposite sides being equal, that's actually a property of a parallelogram, which is actually true. I want you guys up here to put this in parentheses. Parallelogram, right? A rectangle is also a type of parallelogram. So not only is it a quadrilateral, more specifically, it's a quadrilateral that is a parallelogram. So you could also kind of reword it to say that a rectangle is a parallelogram with 4 right angles. That's a little bit more specific in terms of the definition. So because it's a parallelogram, everything that we learned last class also applies to a rectangle. So we're going to go ahead, this is just another review, we're going to write down everything that we know about the parallelogram, and that's also true about a rectangle plus one extra thing that's true about a rectangle. So again, what do you guys know about a parallelogram? Okay, opposite sides are congruent.
I know the next one.
What?
Opposite angles are congruent.
Okay, opposite angles are congruent.
Do we have to write this down? We could just look 2 pages back.
I want you to write them down just so you can see how it relates and then is added on to. So yes, I want you to write it down. Plus, muscle memory helps you remember it. Alright, so those are only 2 things. What's another thing that I know about parallelograms? Nope. Okay, so diagonals bisect each other.
There are 4 sides.
We already took care of that with quadrilateral. Forget what order I put them in. Alright, what's something else?
I got it.
Okay. Keep slow. Consecutive angles are supplementary. So everything that we talked about last time is also true for a rectangle. So these are the 4 main properties of a parallelogram. I also want you guys to include the definition of a parallelogram. So you guys remember what the definition was for a parallelogram? What would make something be a parallelogram? 2 pairs of parallel sides. So I've included the definition of parallelogram and how it would apply to a rectangle as well as the properties. Now these are all true. This is stuff that we already know because this is a parallelogram that we learned last time. These all apply. And then there's one extra thing that a rectangle has as well. Okay? Nope. The right angles is included in the definition. This is a property. This is another property that a rectangle would have. The diagonals are congruent. And then you guys in parentheses can say full length. So if I were to draw a rectangle, if you guys want to draw a rectangle over here, that means that the diagonal from this corner to this corner is the exact same length as the diagonal from this corner to this corner. which was not true in just a regular old parallelogram that we talked about last time. Last time, right before you guys took the quiz, I showed you when it's slanted, there's one longer diagonal and one shorter one. Because it's not slanted and it's upright and has those 90-degree angles that keep it sturdy like this, that makes the diagonals equal to each other. So this is something new, right? Everything that we learned last time is true, but then there's one extra for rectangle. Okay, so just, I told you this unit's a lot of remembering. So you have one extra thing to remember about a rectangle. So, with that under our belt, let's see if we can apply that to these pictures here. So this is telling us, I know the letters aren't there, but this is A, B, C, D. I'm illustrating how you name a quadrilateral. You pick any quarter you want. So if I start in the top left, you have to name them going around clockwise.
Can I start on the bottom left?
Like here?
Yeah.
Yeah, but then it would be A, B, C, D. Just make sure you pick a corner and then you go clockwise around to me. Okay? Now, the way that I've named it here, it says the measure of ACB. So in order to create angle ACB, I'm going to have to do this. So I like to highlight what I'm looking at. This angle right here is 38. And I want to find the measure of BAC, which is right here. So in order to get the angle they were describing, the ACB, I had to draw a diagonal. So sometimes you guys will have to add a diagonal to get the angle. Just be aware of that. All right, how do you think I would find that angle marked with an X? What's something else I would need to add to the picture using the fact that it's a rectangle? Right angle, maybe? How would that help? I have to find X angle. Yes? What do you mean?
Oh, so it all equals 180.
So the triangle? So you can use does anybody remember what it's called? Triangle sum theorem. Because this is a triangle, if you draw a diagonal, it splits the rectangle into two triangles. These three angles should add 180. So x plus 38 plus 90 equals 180. So you guys will actually find a lot of the times when you guys are working in rectangle, squares, and rhombi, you use triangles instead. A lot of the time. So keep your eyes peeled for triangles. Alright, so now I'm going to add these. That would be, oops, that's supposed to be a plus, right? And then I subtract, that would be 52. Yep, 52. 52 degrees. So again, if you guys need me to illustrate a little bit more, we have a right triangle over here. If you need to draw it off to the side, that's what we're working with. Does everybody see that? If you need to draw it off to the side separate, feel free to do that. It's actually really helpful visually. Alright, so what we used about the rectangle was this 90-degree angle. Okay. What about this one? We have X, Y, Z, W is a rectangle. The diagonals intersect at O. See how they're describing the diagonals, but they weren't in the picture, so I'm going to have to add them.
What's that little dash right after the sentence?
Say again? Oh, this is where we're going to write our answer. Oh, sorry. That's what the answer is for. Or where the answer is supposed to go. Alright, so do you guys see how in the question it mentioned diagonals, but it didn't have them drawn? So if they mention something, you have to draw them yourself. They're intersecting at O, so this point is O right here. XO, this length right here, is 6x plus 1. That x as a variable is different than the x in the corner. Just be aware of that. And then YW, which is the entire diagonal right here, is 20x minus 30. I want to find the length of a diagonal. Now, in order to find the length of a diagonal, what would I have to find first?
The length of the line?
Well, they're saying that the length of a diagonal is represented by this expression, which is not a number. If the length is being represented by this, what would I need to find?
What it equals to?
No. If they're saying that the full length is equal to 20x minus 30, I don't want to write 20x minus 30, I want a number. What do I have to find first?
180. What x is worth?
What x is. I have to find x, so I can plug it in. Okay? So we have to take a step back before we can actually find what the diagonal is. I have to solve for x. So what property would I use to help me solve for x? About the rectangle. Okay, so you have diagonals, so you guys are thinking about the diagonals, right? The diagonals cut each other in half, correct? Okay. But this is talking about this diagonal, and this is referring to the other diagonal. So you guys need to think a little bit more strategically. If I have something on this diagonal and then on this one, what's the relationship between the two diagonals to each other? They're equal. That's the new thing about a rectangle. For a rectangle, this right here is going to be equal to this. That's the only way I can write an equation. So what equation could I write? 6x plus 1 times 2. Sorry, not going to mush. Hold on. Equals. Great. Because the 6x plus 1 is only talking about half of the diagonal, and this is talking about the whole diagonal. So the whole diagonals are equal to each other, so I need to put another 6x plus 1 right here, so I get the full diagonal. You can either add them together or just say it's times 2. Okay, so then I can solve this equation. This is really 12x plus 2 to get the full diagonal here. That's equal to the full diagonal yw, which is represented by that equation, or expression, sorry. Now what? I'd actually subtract the 12 over so it stays positive. I think that's probably a little bit easier. So if I have the 8x and then I add the 30 over here, x is equal to 4. Is that what I was after ultimately? Was I asked to solve for x? I was asked to find the length of a diagonal. I had to step back to find x. Now I have to step forward again. I'm going to take the 4 and plug it in. So 20 times 4 minus 30. So make sure you guys are always keeping your eye on what it is you're actually looking for. You may have to go off to the side and do something else. Don't let that extra busyness off to the side distract you from what you're ultimately after. Okay? So I just find x first and then go back and plug it in. So does everybody understand how I use that property of rectangles for this one? If you guys are trying to write a relationship between the two diagonals, just remember that the diagonals are equal to each other. Full diagonals. Alright. A couple more and then we'll move on to a rhombus. Alright. A rectangle is shown. So make sure you guys are reading the directions that it says it's a rectangle, otherwise you can't use any of the stuff we know about a rectangle. If QC is 2x plus 1 and TC is 3x minus 1, find the value of x. So we're solving for x. Which property would I use?
Could you do the same thing like 3x minus 1 times 2 equals 2x plus 1 times 2?
Okay, so what property of a rectangle would I be utilizing? What do I know about the picture that allows me to move forward?
Is the property the same one as the last one?
Sort of. Well, the diagonals bisect each other, right? So if this is 2x plus 1, what's this?
So 2x
And if
plus
this
1
is 3x minus 1, what's this?
3x minus 1.
So that's using the bisect idea, but then how do I actually link them together?
Add.
The full diagonals are equal, right? So I can say that 4x plus 2, this full diagonal, is equal to this full diagonal, which would be
6x minus 2.
there you go, and then you just do the algebra. Okay? So now I would subtract this, I get 2x, add that, I get 4. X is 2.
Couldn't you just put 2x plus 1 times 2?
That is what I did. I multiplied that up. Yeah, you can definitely do that if you want to. You can take an extra step like this to write it out. For sure you can do that. I just kind of did that in my head.
Oh, okay.
But yeah, it's the same thing. Alright, everybody clear on that one? So I used both of the diagonal properties together. I used that they were being bisected in order to get equal parts, and then I said that the full lengths were equal. So I used both of them together. Yes? Yes. Mm-hmm. So that's actually a shortcut. Because the full lengths are equal, wouldn't the halves of each of them be equal too? So you can go straight to saying those are equal. If you're strategic enough to see that, you can go straight there. But if you kind of want to work through the process, a lot of students prefer to do that, to just use properties instead of shortcuts to work through it. You'll get to the same answer eventually. Just might take a little longer, but it's still accurate. All right, now we're going to work with some angles. Okay? All right, if I know that the measure of angle 1 right here is 30, I am looking for the measure of angle 2. So this one you're going to have to stretch your brain a little bit more. Okay? What can you guys tell me about a rectangle that I can
They're all
apply?
equal size. Or like the top and the bottom are equal size.
This and this?
Yeah.
That is true, but I'm not sure it's going to help us with our angles.
Like the top and bottom are equal and the left and right are equal, so wouldn't you just like do 180 minus 30 and then whatever that is divided by 2, because whatever the 2 is equal to the length.
This one?
Yeah.
Okay, but that's not because these two are equal. What you're saying is true, but not because the outside sides are equal. Okay, we do know that opposite angles are congruent, but that would be like this full angle and this full angle. That's not what we're talking about. Do you guys see how I drew the diagonals? If I drew the diagonals, you guys have to use them somehow. So let's think about the diagonal properties again. What do we know about the diagonals? They bisect each other. Okay, so each of these are being cut in half. What else do I know about the diagonals?
Diagonals are congruent.
The full lengths are equal, right? So kind of like Kayla was referring to before, if the full lengths are equal, and I'm cutting them each in half, what do I know about all 4 of these pieces? They're all equal to each other. This is not true for just a run-of-the-mill parallelogram that we were talking about before, because the diagonals are not equal lengths. If the diagonals are equal and they're cutting each other in half, then all 4 of these are equal. So look very carefully. Do you guys see a triangle in here anywhere?
Yeah. The triangle with the line.
This one? If I go off to the side and I draw that separate, what kind of triangle is that? What do we know about angles in isosceles triangles?
Side.
2 congruent sides means
Congruent angles.
which ones?
75 and 75.
Or position-wise?
The top one and the bottom one?
This one and this one?
No, 2 and
No,
length.
This one
Yeah.
and this one.
Yeah.
Right? We call those base angles. They're the ones along the base, the side that's not equal to the other 2. So now that these 2 are equal, I'm going to go ahead and call it x instead of 2 because that's confusing. So I know that both of those are equal, so I can say that 2x plus 30, what do I know about all the angles together? So a little bit of algebra will get you what you need. 50 divided by 2. Sorry, 150 divided by 2. So something that's important to remember about a rectangle, using the 2 properties of the diagonals together gives us 4 different isosceles triangles when the diagonals are drawn. You have these 2 right here and these 2 right here, isosceles triangles. So don't forget, the triangles are really, really important when you guys are solving inside of a rectangle. They'll save your life when you guys are trying to solve questions. Alright. Everybody okay with that one? So
Yeah.
look for the triangles as much as you can. Alright, angle 6 is 57 degrees. I'm looking for angle 4, which I'll call x just to make it easier. Alright, what do you guys think for this one? Am I going to be using isosceles triangles again? Okay, what do you think? Where? You guys see that? I knew up here that the triangle I was using is the one that had the 30 and the 2 in common. So that's why I knew I was using this triangle. The triangle that has the 57 and the x in common is this one that's half of the rectangle. You guys see that? So the triangle I'm using is over here. I have a 57 and an x.
Use the triangle sum theorem.
I can only use the triangle sum theorem if I know all 3 angles,
Oh, okay.
which I don't have marked yet, but I can. What do I know about this one?
It's a right angle.
Because it's a rectangle, right? So once I have that here with the 90, then I can use the triangle sum theorem. This plus this plus this equals 180. Yep. So there you go again, using a triangle. Using another triangle. It was just a different triangle. So look out for which triangle has the angles in common. Maybe use a highlighter or something and physically draw the triangle, and it'll really help you solve using that particular triangle and rectangle. Alright, let's try this last one before we go on to a rhombus. So I know that angle 5 is 16 degrees, and I'm looking for angle 3, which I will call x. All right. Now, is there any triangle that has both x and 16 in it? Is there any triangle that has just those two in common?
Can't you just do the same thing again?
What same thing?
Like
Where
right
you have
Yeah.
it?
90
Well,
minus
but
16.
do you guys see how x is only referring to this angle right here?
Yeah, but that angle is the same to the other two.
It's
So
the
which one?
To on the left.
Here or here?
No, on the other side.
This one.
Yeah, and the one below.
Okay, it is true that that's x.
So the
but,
90 minus 16 fill in that gap and whatever that number is, put in the same angle on that side.
I'm not sure what you're describing. You mean like 90 to find this one?
Yeah, 90 minus 16.
But we don't know what this angle is.
But that's 16.
How do you know?
Because that angle on the bottom is equivalent to that one.
Why?
Because it's also in the isosceles triangle.
We're going back to our isosceles triangles. That was kind of a really roundabout way of saying it, but you'd eventually get there. So, do you guys see how this bottom triangle right here, again, when you guys take note of the diagonals bisecting each other and the fact that the full lengths are congruent, all four of these are equal, making this an isosceles triangle. So if this is 16, what's this angle right here?
16.
Also 16. Now you can go along with what Adrian was saying. We use the alternate interior angles to put the x here. I can use this right triangle and the 90 degrees. There's a faster way. So the original x is right here. What do I know about these two angles together? They're 90. So it would be a little bit faster if you put the 16 here and just say that x plus 16 equals 90. You can still do what you were describing. But this would be faster because we know 90 degrees. Those two angles add together, they're complementary.
So x is just equal.
How do you figure out if they're congruent?
Which ones? Like the 16 here?
No, like the lines.
This one?
No,
Oh,
the
these.
They're all
Because the full diagonals were equal to each other. So let's say this was like 10 and this was 10. But the diagonals also cut each other in half. So if this was 10, each of these would be 5.
Yeah.
But this was also 10, so each of those would also 5.
Can they ever
But can there ever be like that they're not?
Only
congruent?
if it's slanted. When we were talking last class with the slanted diagonals, or sorry, the slanted parallelogram that looks like this,
Okay.
this diagonal is longer than that one. So that's why
Alright.
the parts are different.
So if it's a
We wanted-
rectangle, it's always gonna be congruent. But if it's diagonal like a diamond, then it won't.
Great.
Alright, I get it.
Yes. Alright, everybody clear with the rectangles?
Yep.
Look for those triangles. The triangles help you most when you're trying to find angles. When you're using other things like the diagonals and segments and stuff, you don't use triangles as much. It's usually for the angles.
This can
Yes, sir.
those would be all to put with all the diagonals and then you put
So I might have the diagonals already there. You might still have to find the triangles, but I don't think I would ask you to draw the diagonals. Probably not. All right, now we're going to move on to a rhombus. Have you guys ever worked with rhombus before? No?
No.
Okay, a rhombus is a quadrilateral, in parentheses, parallelogram, above, with 4 congruent sides. Okay, so rectangle was a parallelogram with 90-degree angles. That's all we really needed. A rhombus is a parallelogram with 4 congruent sides. So does a rhombus have to have 90-degree angles? Does a rhombus have to have 90-degree angles? No, the only thing that would qualify something as a rhombus is that it has 4 congruent sides. So a good representation of a rhombus would look like this. Kind of like a diamond. So it's kind of like a
Their angles are different, but the sides are the same.
correct. The angles don't have to be, but they could be different, but the sides all have to be the same. Yes. Okay? Now, because a rhombus is a parallelogram, everything that we talked about for parallelogram is still true. So I'm just going to, instead of writing it again, just like we did on the first page, I'm going to say properties of a parallelogram. I'm just going to write that down. You guys need to reference those again. You have them on the previous page as well as the first lesson. Or sorry, the second lesson. Okay? So because a rhombus is a parallelogram, everything that we have known about parallelograms also applies. So opposite sides are equal, opposite angles are equal, diagonals bisect each other, consecutive angles are supplementary, and opposite sides are parallel. So everything that we know about a parallelogram is true about a rhombus. Now, what about that extra thing we learned about the rectangle, that the full lengths of the diagonals are equal? Does that apply to a rhombus? No, that is unique to a rectangle. That is special to a rectangle. A rhombus also has two extra features that are specific to a rhombus. Okay? Which one do I want to do first? That one sounds good. Alright, diagonals are perpendicular. Start with this one. Diagonals are perpendicular. You guys remember what perpendicular means, right? Not too far. Perpendicular means that when they cross, they create 90-degree angles. So if you guys want to, you can draw another rhombus over here. If you guys were to draw the diagonals in a rhombus, it would make a 90-degree angle. Or four, really, but we usually draw one. So where the diagonals cross, it's 90 degrees on the inside. So that's what it means that the diagonals are perpendicular. The last thing that we know is that diagonals bisect angles. Diagonals bisect angles. So anytime a diagonal touches an angle, that angle that it touches is being divided in half. So if I drew another illustration, this visual is always helpful. If I draw this diagonal, and you can draw both, but it would probably be neater to just draw one, it's going to cut the angles in half. So whatever angle it's going through when you draw a diagonal, it's going to chop that angle in half. Okay? And the reason why I drew these single markings is because I already know that opposite angles are equal. So if these angles are equal, then the halves are equal too. So kind of just like how the diagonals work for the rectangle. Alright, so there's a little bit extra you have to remember about a rhombus. I understand there's a lot of things to remember. I warned you guys when we started that that was going to be true. So everything that we talked about for parallelograms last class, as well as the diagonals being perpendicular and bisecting angles. Okay? Great, let's see if we can apply that here. I know that ABCD is a rhombus. We're going to find the measure of BAC, which is right there. So, what can you guys tell me about a rhombus that I could use to help me solve here?
Diagonals bisect angles.
Okay, so that means that this diagonal, these two would be equal, and these two would be equal. What else? That doesn't quite give me enough to get all the way there. Yes?
All sides are
Okay, so I can take the definition of a rhombus and go like that. How does that help? Hmm? How does this help? Where? Okay, so you guys see, again, triangles. You guys see triangles?
So
This triangle right here, you guys see it? ABC. This is what kind of triangle? Isosceles. I know that this is 41, sorry that's really small. And this is X.
so x equals 41.
Yes. I use a triangle again. When you draw that diagonal, these two sides are equal, making it isosceles, and the two base angles are going to be equal to each other. So this is 41, that's 41. Alright. So again, look for those triangles. They really, really help. Alright, again, I have to write in the letters. So K, L, M, O is a rhombus. Again, make sure you guys are reading the directions to know what shape you're working with. The measure of angle O is 1/12. Go ahead and add that into your picture. I am going to find LKM. Where is LKM? Angle K would be LK.
LKM is like a bisect.
Do I have LKM currently in the picture?
No, you need to draw it on.
You need to draw diagonal. LKM is right there. So again, here's another one where they were referring to an angle that wasn't there yet. You have to draw the diagonal to actually create that angle. And that's what I'm looking for. All right. So, What would I do knowing that this is a rhombus? What's something I know about a rhombus that can help me out?
All sides are congruent.
Okay, so you can put that in.
Doesn't that mean that 112 could be flipped onto the other side as well?
Where?
LK.
Here?
Yeah.
Okay, but that's not using the fact that all of these sides are equal. What property would let me say that this goes here? Opposite angles are equal. Because remember, this is still a parallelogram. Everything that we talked about last class also applies here. Opposite angles are congruent for parallelograms. So I can take this 112 and put it there. Awesome. Now what? Oliver? Okay, can you tell me why that is? Okay, so we're going to do the same strategy we did over here. You guys see how there's an isosceles triangle again, using the congruent sides? This one right here. So I know that this is 112, this is x, and these sides are equal. I can also say that that's x.
So 2x plus 112 equals 180.
Yep. So I used that it was isosceles to say that these two angles are equal, just like we did over there. I just put, since this was x, that's also x. I just fill in the blank there. And then I use the triangle sum theorem. Yep. Alright, so again, the triangles in there really helped us.
Are we gonna take a test on this? I mean, like, but when though?
It's on the front of your unit guide tells you when the test is.
I'll check.
Alright,
Okay.
alright. We have another rhombus. You guys help me out. What would I do?
You do, well, like, always 90, so.
A good thing to do if they're talking about an angle in the question but they haven't marked it as an X in the picture is to do that. Mark it with an X. Because if you can visually see what you're after, it really helps. So I'm after this angle right here. PRS, that one.
Oh, PRS.
Yes. So if you can highlight it, PRS, that one. Yes.
When did you, since you said, like, there's that rule where all,
Diagonals are perpendicular.
like, all of, in the middle, they're all 90.
Okay, so that's a really good point. I'm just going to draw a box like this because all of them are 90 degrees, so I just like to draw all of them. So 90, 90, 90, 90 all the way
So that's
around.
one.
So 180 minus,
Hold on. Pauline? Yes, go ahead. What are you seeing?
180 as well.
Where?
On the top two right angles. S and R. The angles on top of S and R. The right angles on top of S and R. Like in the middle.
Oh, these ones?
Yeah.
Oh, the
Yeah, those.
180? The fact that they're a linear pair is not necessarily going to help us.
Alright.
Remember, what shape do you guys want to look for?
triangle.
Triangles. What's a triangle? Not isosceles, because we don't know that the diagonals are equal. Remember? That's only for a rectangle. The isosceles are like half of a rhombus, not a fourth of a rhombus.
What about like
What triangle would I use to help me solve for? I have everything I need.
Right.
No, which triangle? Name it. P-O-R. This one. This has a 90, a 57, and an X.
So you just do 57 plus 90.
just 47 and that's X equals.
Another triangle sum theorem. Again, triangles. Okay?
It's 33.
32. Okay. So that goes up here. Just about the video. Alright, so we have ZURM now. Z-U-R-M is a rhombus. Alright, we have ZU, which is a side. We're going to call that 7x. ZM is 3x plus 10. And UR is y. And I want to find the values of those variables. So what can you guys tell me about a rhombus that will help me solve?
All sides are equal sides, right?
All sides are equal for a rhombus. That's the definition. So how can I use that to help me create an equation that I can solve?
Isn't it just like
3x
360
plus 10
minus
equals
divided? Can't you just do 360 divided by 4 if they're all equal?
No, that would be the angles, not the sides. The sides do not add to 360.
No.
Neither do the sides in a triangle
Oh.
add to 180. I've seen it before. That is not the
3x
case.
plus 10 plus 7x plus y.
Why are you adding the sides?
No, 3x plus 10 equals 7x.
Okay, there we go. All the sides are equal, right? If you need to, draw the little markings to say that they're equal. I know that this side is equal to this side, correct? The 3x plus 10 is one side of a rhombus, which should be equal to the other side of a rhombus. Now, why didn't I start by saying that 3x plus 10 is equal to y? These are two variables. Remember, don't mix them if you can avoid it. These two sides both have x, so I'm going to stick with those two. Thankfully, not just the opposite sides are equal, all of them are equal. So even though these are next to each other, because there's a rhombus, I can say they're equal. So I'm going to go ahead and solve that. I think it's going to give me a decimal. 2.5. So x is 2.5. Cool.
So then you just plug it in.
Where?
So 3x and x is 2.5. So
Okay.
3 times 2.5, which is 7.5 plus 10. So 17.5 equal 1.
Okay, so I can plug in x now that I found it. Do I need to plug it into this one? Is that the only option I have?
No, you
Plug
could
it
plug it
into
in.
I
as
could
well.
also plug it into that one, right? Get the same answer. So if I plug it in there and I get that side is 17.5, what would the value of y be?
17.5.
Right, because all the sides are equal. And y is representing one of the sides, so it should be 17.5.
So all sides are 17.5.
Correct. That's the definition of a rhombus.
How'd you get the 2.5? I wasn't paying attention.
The sides are equal, right? Not just the opposite ones, all of them are equal in a rhombus. So I said that the 3x plus 10 is equal to 7x. I just solved it.
Oh, and then you did the all capital.
Alright, we're almost done with the rhombus, and then our last one's a square. Alright, so this one says that the perimeter of a rhombus is 68. Okay, it is also giving us that segment BS is 8, and I'm going to try to find SC, which I'm going to call X right there. Now, they gave me the perimeter, not just for fun, I need to use it. How would I use the perimeter to help me in a rhombus?
Divided by 4.
Divide by 4.
You get
Why?
17.
Because all sides
the
are
same.
equal.
Okay, so if I divide this by 4, that would give me one of the sides.
17.
17. Then I go 17, 17, 17, oops, 17. That's right. Okay. Cool. I need you guys to give me one more thing about a rhombus so that I can actually solve this. Well, here, first of all, which triangle or what part of the shape am I going to be focusing on now?
BCS.
This right here. Because this is the triangle that has x in it has an 8, and it has a 17. So that's the triangle that has the most information. But I can't move forward with this until I get a little bit more information about this triangle. So if I just have a triangle that looks like this, can't really do anything. Just with that. Okay, that would give me that this is 8 and this is x, which is still in the same position. Need something else. What is this? This should look familiar.
Is it an isosceles?
No, it's not
Is it
isosceles.
Right angle?
Why?
Because
All angles in the middle.
Why?
The opposite happens.
because
What do you know about the
creates a square.
diagonal?
diagonals are perpendicular.
The diagonals are perpendicular, so I can put a 90-degree angle right here. With this being a right triangle, how can I solve for x? Pythagorean theorem. Last unit, Pythagorean theorem. When you have a right triangle, and you guys have 2 of the 3 sides, you can use the Pythagorean theorem to solve. So you guys will be seeing stuff from other units coming into play. Because this is a right triangle, you may be expected to use information about right triangles. Sometimes trig, sometimes Pythagorean theorem, sometimes the special right triangle rules. That's why unit 7 is before this one.
So 8 plus x plus 17 equals a 180.
No, that's if they were angles. These are sides.
So
Oh,
What's the Pythagorean theorem?
a squared plus b squared equals c squared.
So this is A and B. This is
Six,
C.
and so it's 64 and 289. So x is 7.
So 8 squared plus x squared equals 17 squared. They go in each position in the Pythagorean theorem. You subtract, I don't know what 17 squared is, but you're going to subtract 64 from that. 225. And then you're going to take the square root of 225.
15.
Wait, how is it?
What's wrong?
When did I lose myself?
You need to make sure that the slanted side, the one across from the right angle, the diagonal, the 17 should be on the other side. Alright, so you guys are really good with seeing the isosceles triangle, knowing how to use the isosceles triangle. You also need to be able to know how to work with a right triangle if you see that. So don't forget stuff from last unit. Alright, almost done with the rhombus. Alright, the measure of BAC is provided for you is 28. I want to find x, which is right here. Now, what shape? Do you guys see how in every other shape or question I said what shape it was? Didn't say that here. So if you guys don't see, if they don't tell you what shape it is, you have to look really quickly, decide what shape it is, because depending on what shape it is which properties you'll be allowed to use.
How do we find a shape?
Just by looking at it, it's a
What-
rhombus.
How do you know it's a rhombus?
Because it looks
Both
like
sides
diamonds.
are the same.
There's a marking in here that will let you know
A little dash.
all the sides are equal.
I said that.
So that makes it a rhombus.
I said all sides are the same.
But how do you know?
There's a little dash. I said that.
I know, I heard you. Somebody else said it too. Alright, so once you've determined what shape it is, if they haven't told you already, I've determined it's a rhombus. Now I can use properties of a rhombus and parallelograms to solve. So what would I do first?
There's a
So
little triangle.
all the middles are 90.
Okay.
So then the 28.
You can add stuff in here that you're not going to use.
Wait,
It's
isn't
totally
x
fine.
just 28?
Why?
Because it's all sides are equal, and since what's it called? The middle angles are 90, and
The
it's
x
not
equals-
it's not an isosceles triangle, so the diagonal between D and B and C it wouldn't equal the same.
I did not
Can't
follow
you do
that.
the Z so the X will equal?
Okay, hold on. Question rather than suggestion. What's your question? Okay. Yeah, so a rhombus is a parallelogram. Which ones? Which ones? If a rhombus is a parallelogram, would these be considered parallel? Yes, definition of parallelogram. So then if I have a z, then the value of x would be 28. Now, that's just one way.
Said that.
That is just one way of doing this. There are so many different ways that you guys could solve for this one. You guys could also use the property that the diagonal bisects angles. You could say that this is also x and this is also 28, together with the fact that the opposite angles are equal. So you could do 28 plus 28 equals 2x. Solve it that way. Right? There are so many different ways that you can solve this. Just go with any valid property that you see first and go with it. Whether it's short or long doesn't matter as long as you understand what you're doing. Don't try to look for the shortest way, look for the way that makes sense, as long as it's valid. Okay? So yes, you guys do need to remember everything that we're talking about today. The rectangle, the rhombus, and the square are all parallelograms. So anything you know about a parallelogram, you can also use to solve. Okay? Alright, last one here. The measure of angle A is represented by this expression. How do I solve for x? Measure angle A is right here. Okay, so we're going to use the property of a rhombus. What do we know about where the diagonals meet? They're all perpendicular. So what would the measure of angle A be?
90.
So if I know it's equal to 90, but if I have an expression for it, I know that those are equal to each other. The expression for angle A is equal to 90.
Wait, are these two? Is the bottom of like this question the same as the top question?
No, these are two different shapes. This is talking about this is talking about this one. Again, we know this is a rhombus because all the sides are equal. So we can use the property of a rhombus. Sorry, I should have done that first. We know it's a rhombus, even though the directions didn't say so. We know it's a rhombus because all the sides are equal. Then we can say, oh, I know that these are all perpendicular, so this angle is equal to 90, and then I solve. So I don't know, what's 84 divided by 6?
5.25.
Really? 5.25?
Oh, should have talked about that in the second floor.
Okay. Don't be scared of decimals, you will get them. right? So a rhombus has everything for a rectangle plus the perpendicular diagonals and the diagonals bisecting angles.
This, where's X?
Hmm?
Where's X?
Here. It was.
Oh,
this
that's,
is too small
I
of a
was
picture.
so confused.
It was
I
too
thought-
small for me to write in, so I just underlined it. Alright, lastly we have our square. Okay? I'm not going to focus too much on it because the definition of a square is interesting. So a square is a... I'm going to write parallelogram instead of quadrilateral to save space. A parallelogram with 4 right angles and 4 congruent sides. Make sure you write that down. A square is a parallelogram with 4 right angles and 4 congruent sides. What was a rectangle again? Parallelogram with 4 right angles and a rhombus. A parallelogram with 4 congruent sides. Mush them together, you get a square. So a square is a rectangle and a rhombus at the same time. So everything that we have talked up until now is true about a square. I'm just going to write the word everything. So everything that we've talked about last lesson and today, everything that's true about a parallelogram, everything that's true about a rectangle, everything that's true about a rhombus is true for a square.
Everything is true.
Sure. So everything we've talked about up until now is also a property of a square, because a square is both a rectangle and a rhombus at the same time. Right? So here's a picture of a square. I would like to know what the measure of y is, please.
90.
Y is equal to 90. 15y is equal to 90, and then I'll have to solve that. The expression is equal to 90, then you solve it to find y. So what would the value of y be?
6.
Okay, easy enough, right? I used the what property did I use for a square to figure that out?
All angles are equal.
More specific?
All angles are zero.
All angles are 90 degrees, right angles. The definition of a square. Okay? All right, deep breath. Here's our last one. ABCD is a square. AB is equal to 5x plus 2y. AD is 3x minus y, and BC is 11. What should you notice about what's going to happen with this question?
So 3x minus
Hold on. Just by looking at the picture, I told you guys last class, a light bulb should go off in your head by the way that the label. System. When you guys see a label that has an x and a y, and they're together, we like to keep our variables separate. If they're already stuck together in the label, you're going to have to use the system that we were talking about last time. Okay? So, make a mental note. That is going to happen. Now, what equations could I write?
3x minus y.
All sides are congruent.
All sides are congruent. That is correct. So what's an equation I could write? 3x minus y equals 11. Okay? What's another one? We could also say that 5x plus 2y. Oops, sorry. I don't know why I do that. I have this weird thing where I accidentally write y's and 7's interchangeably. Okay. Alright, so we have this. Again, this is a system. So if you guys remember from last time, and I did ask you to review systems if you're weak with that topic. For you to solve a system, you need the x's in a column, the y's in a column, then the equal sign, then the numbers in a column. So that's actually happening for us. So the x's and the y's, then the numbers. So that's all good. The next thing you want to check is you're going to pick a variable. Which variable would you like to get rid of first?
Y.
The y? Okay. In order to cancel out the y, I need the two numbers in the front to be the same but opposite signs. Right now this is a -1 and this is a +2. I want them both to be a 2, but negative and
So
positive.
you add 2 to
Don't add.
you times
Multiply the entire top equation by 2. 6x minus 2y equals 22. So I'm going to ignore the top one since I've changed it. Then you guys are going to add down. What is 5x plus 6x? What happens to the 2y plus -2y? They go away, hence the elimination method. And then 11 plus 22. Solve that. X is equal to 3. Now, I found one of the variables, I need the other one. I know the directions just say to find x, but I also want to find y. So how would I find y? Plug it into either of the two equations that you had in the beginning. So I will do 5 times 3 plus 2y equals 11. That's 15 plus 2y equals 11. Negative 4y is equal to negative 2.
Wait, what?
When you find the x, you plug it in.
I'm so lost.
Where?
Okay, I get 3x minus y equals